Lesson 4 is the midpoint formula, and the midpoint is like a middle point on a line segment. So 4.1 is finding midpoints and endpoints of segments. So starting with the midpoint formula in the upper left. So it says the midpoint M of segment AB with endpoints A and B can be found using the following formula. So the formula is M, and that M is really just like the name of the point because we name points with just letters, so M for midpoint. But it's x1 plus x2 over 2, and then y1 plus y2 over 2. So really what it is, it's you're finding an x and a y coordinate from or for the midpoint, and you can even see like the formula is structured like a point where there's like parentheses with the comma separating the two values. And like the x1 plus x2 over 2, really you're finding like the average, these two together divided by 2 is finding like the average or the mean of the two x values. And then same thing with the y. If you're adding y1 and y2 and dividing it by 2, you're finding the average of those two. So what the midpoint formula is it's kind of like the average of the x coordinates and the average of the y coordinates put together to give you that midpoint. Okay, so example 1, what are the coordinates of the midpoint M? So have the same formula like down here, just M equals x1 plus x2, or not M equals, but the midpoint is x1 plus x2 over 2, and then y1 plus y2 over 2. So it doesn't really matter which point you label as your like x1, or sorry, which point is like your point 1 or point 2. And this one is even more forgiving if you accidentally kind of mix it up halfway through because you're just finding the average of the two numbers, so it doesn't really matter which one you list first. So we'll say for our midpoint M, x1 plus x2, we need to add the two x coordinates, the one from each point, so it'd be -3 plus 4. And then over 2, and that 2 in the denominator is always there, it's not going to change. And then for the y coordinate, you're adding the two y values, so 3 plus -2, or just 3 minus 2 over 2. So the first part of the formula is adding the two x coordinates, the second part is adding the two y coordinates. These are my x's, and then these are my y's. And then from there we just simplify, so the midpoint is, if I add my x coordinates, -3 plus 4 is 1 over 2. And then on my y values, 3 minus 2 is also 1 over 2. So the midpoint is at 1/2, 1/2. And you really shouldn't like try to estimate the midpoint from the graph because it can be hard to get it exact. But once you get your answer, you should like look at the graph and make sure it makes sense in context. So like the point 1/2, 1/2 is like on the line, and like it looks like it's in between point A and point B. If you got like, say you messed up a negative or something and it gave you like -1/2, 1/2, then that would be like an indicator that like you did something wrong because it doesn't even look like it's on the line, and the midpoint has to be on the line segment. So just once you get your midpoint, just make sure it makes sense in the context of the problem. Example 2 says segment CD has endpoints at C and D, with C at coordinates 5, 8. Segment CD also has a midpoint M at 3, 9. What are the coordinates of point D? So in example 1, we were given the two endpoints up here, and we were asked to find the midpoint. For example 2, we're given the midpoint and one endpoint, and we want to solve for the other endpoint. So to do this, we kind of have to like work backwards to create equations. So it says that CD has a midpoint at 3, 9. So I'm just going to go ahead and write that under the midpoint formula. So midpoint M is the point 3, 9. And this is going to be kind of like the basis of our equations, because this like x1 plus x2 over 2 is what we would put things in to get the fact that the midpoint is 3. So that can be one equation. So it could be x1 plus x2 over 2 equals 3. So that's going to help us find a missing x coordinate. And then for the y values, y1 plus y2 over 2, that's what we would use to solve and to find this 9. But we already know that it equals 9 because we know the midpoint. So then we're able to set up an equation that way. So it'd be y1 plus y2 over 2 equals 9. And before we move forward, we have to specifically use 3, 9 as our point that we set the midpoint formula equal to. We couldn't have used 5, 8 because the midpoint formula finds the midpoint. So we have to use the point that says it's the midpoint specifically, otherwise it'll get messed up. And then now the equations that we created, they each have 2 unknowns. In order to solve, we really just need them to have 1. So like x1 and x2 is 2 different unknowns we can't quite solve for yet. And then same thing with the y equation. But we have an extra point that we haven't used yet in this problem. It says that, segment CD has an endpoint at C, and C has coordinates at 5, 8. So that's going to be one of our points that we use for an x and a y. And you can say that it's like x1, y1, or x2, y2. That part doesn't matter at all. But the big thing is just take the 5 and we'll put it in for, I'm going to do x2. Like I said, it doesn't matter between like x1 and x2. And then for the 8, I'm going to put that in for y2. And then now once I put those in, I'll only have 1 unknown, so I'll be able to solve for it. So it would be x1 and then plus x2 was 5. And then over 2, but then after that equals 3. And then, so I put the 5 in for x2, and then now I'm going to put the 8 in for y2. So it'd be y1, and then plus 8 goes in for y2 over 2, and then equals 9. So now my x1, y1, those are my only unknowns. Those are going to end up being the other endpoint. So with a problem like this, you have to make sure you kind of set the equations equal to your midpoint based on the midpoint formula. And then you can take the extra point that you know the endpoint and put those in for either x1, y1 or x2, y2. Okay, so now to solve each equation, I'm going to start on the x's over here. I need to clear the denominator, so I need to get rid of that 2 that's down there. So in order to do that, I would have to multiply both sides by 2. And then the 2, being multiplied is going to cancel out the 2 in the denominator, so it'd leave me with just x1 plus 5 equals 3 times 2 over here, so 6. And then my ultimate goal is to get the x1 by itself, so I'm going to subtract over the 5. So it'd be x1, and then 5 minus 5, that cancels out. And then I'm left with 6 minus 5, so 1. So my x1 is going to be 1. And then over here, I'll kind of do the same thing on my y equation. I got to clear that 2 from the denominator, so I'm going to multiply both sides by 2. And then the kind of multiplying by 2 and the 2 in the denominator cancel each other out, so I'm left with y1 plus 8 equals 9 times 2, so 18. Still trying to get y1 by itself, so I gotta subtract over 8. And then I'll bring down the y1, the 8 minus 8 cancels out, and then I'm left with 18 minus 8, so 10 for y1. And then those two values together, the x1, y1, are gonna be my missing endpoint. So x1 was 1, and then y1 was 10, and then the missing endpoint we're trying to find were point D. So our final answer would just be that D is the point 1, 10. Okay, so just to kind of zoom out and look at these both as a whole, when you have the 2 endpoints, at the end of the segment, you get to use just the midpoint formula, kind of more straightforward. When you have a midpoint and an endpoint and you're trying to find the other endpoint, you kind of have to use the midpoint formula to create equations that you can eventually solve. 4.2 is coordinate proofs with the midpoint formula for quadrilaterals. So you'll see on my proofs, I kind of have just a lot of things covered up. That was to save a little bit of time with the writing and for the video and everything like that. On the printed version, it's all typed in there if you would kind of like to do the same thing and just add annotations. But yeah. Okay, so before we get into the proof itself, we need to review just a concept about parallelograms and quadrilaterals. So up at the top where it says recall, it says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So given that quadrilateral ABCD has vertices at -1, 3, 3, 1, 0, -2, and -4, 0, we want to prove that ABCD is a parallelogram. Sorry, I don't know why there's a parentheses here, but that's just a typo. Okay, so we're trying to prove this with the midpoint formula. That's not the only way to prove that this figure is a parallelogram. We're trying to steer away from slope and focus on the midpoint formula specifically though. So if you're wondering like, why don't we just find a slope? That's why. Okay, so if we're trying to use or find the midpoint formula, we just reviewed the fact that if the diagonals of a quadrilateral bisect each other, then the quadrilateral will be a parallelogram. So if I draw the diagonals on here, one diagonal is AC, and then the other diagonal is BD. So if they bisect each other, that means that their like kind of midpoint is going to be on the same exact point, meaning like the midpoint should overlap. Versus like if it was kind of off-centered, it may not be or would not be a parallelogram. So our proof, or kind of like the goal for our proof, is to show that the midpoints of each diagonal are the same point. So for our statement number 1, it's always just whatever we're given. So we're just stating our vertices. A is at -1, 3, B is at 3, 1, C is at 0, -2, and D is at -4, 0. And then of course the reason is that it's given. Okay, and then to kind of set up for a proof, we have to just kind of state what I just drew on that picture. You know that AC is a diagonal and BD is a diagonal. So segment AC and BD are diagonals of ABCD. And again, we're working towards like showing that the diagonals bisect each other. That's our goal. So we just have to state that they're the diagonals. And then the reason is just definition of a diagonal. That's what a diagonal is. So there's not really like any other justification other than its definition. Okay, and then for number 3 now, we're going to start working towards like finding the midpoint. So if we want to use the midpoint formula, and I'm not going to like copy down the formula. I'm going to like probably recommend that we start to like steer away from it. Unless you really want it, you can have it, but it's one of those things that it's not so bad without the formula once you get comfortable with it. So I want to practice that. Okay, so we're going to find the midpoint of segment AC. And to do that, we need the points A and C. So it's -1, 3 for A, and then 0, -2 for C. So for the midpoint, you take each of the x coordinates, so -1 and 0, and you add them together. So -1 plus 0, and then you divide it by 2. And then the second part is you take the y coordinates and you add them together. So 3 plus -2 or 3 minus 2 over 2. So this is where I'm kind of stressing, like, if you can get comfortable without the formula, you're just, for each coordinate, you're adding them together and dividing by 2. So this is like the x's added divided by 2. And then this is the y's together divided by 2. So then -1 plus 0, of course, is -1 over 2. And then 3 minus 2 is 1 over 2. So that's the midpoint of segment AC. So that's what we're going to state for number 3. We're going to say the midpoint of segment AC is -1/2, 1/2. And then our reasoning is just midpoint formula because that's what we use to find it. And then for 4, we're going to do the same thing, but for BD, for the other diagonal. So for segment BD, do the same thing, kind of set up our formula. And then the point B is 3, 1, and D is -4, 0. So always over 2, and then the first part will be our x's added together. So 3 minus 4, or 3 plus -4, so 3 minus 4. And then the second part will be our y's added together, so 1 plus 0. So for our x's, it's 3 minus 4, so -1 over 2, -1/2. And then for our y's, it's 1 plus 0, so 1 over 2. So +1/2. So the midpoint of BD is -1/2, +1/2. If we didn't get the same midpoint, then we would probably be in trouble, but we did, so we're on the right track. So 4 is the midpoint of BD. Segment BD is -1/2, 1/2. And then the same reason here is that we just use the midpoint formula. So that's our reason. And then moving down to 5. So we're building towards, like, the midpoints are intersecting each other. We know where they intersect each other now, and so that's going to be our next statement. So segment AC and segment BD intersect. Sorry, I'm going to fix that. Intersect at -1/2, 1/2, which is the midpoint of each segment. So the kind of reason, I don't think we've used this reason before. The first time I read it, I was like, it seems silly. But the reason is if two lines intersect, then their intersection point is exactly 1 point. So basically, like, if two lines are crossing, they must be crossing at one and only 1 point. So for 5, segment AC and BD intersect at those midpoints, -1/2, 1/2, which is the midpoint of each segment. Okay, and then because it's the midpoint though, if we go back up to our picture, so this point right here, -1/2, 1/2, if it's the midpoint, that means it cuts each part into two congruent halves. It's the middle of the line segment. So AC, AC would be cut in half, and then BD would be cut into two congruent halves as well. So that's what we're stating now. So we're going to call this M for the midpoint. So for our next statement, we're going to say that AM is congruent to MC. So AM is congruent to MC, and then we can also do that on the other side as well, or the other diagonal. Say BM is congruent to MD. So basically, each half of the diagonal is congruent to the other half, because that's what a midpoint does. It cuts a segment into two congruent halves. So AM is congruent to MC. That was this part. And then BM is congruent to MD, which is these two parts right here. And then because that's just what a midpoint is, it's like the definition of a midpoint, that's our justification, is definition of a midpoint. And then if a point or an intersection point cuts something into two congruent halves, another word for that is bisect. So if something is bisected, it's cut into two congruent halves. So for 7, we'll say segment AC and segment BD bisect each other at M. Each segment, AC and BD, cut each other into two congruent halves. We said that was 6, so now we can go ahead and confirm that they do bisect each other, because that's what a definition of a bisect is. It's something that cuts something into two congruent halves. And then now I'm going to zoom out and we'll go back up to that kind of recall section. So it says if the diagonals of a quadrilateral bisect each other, which is what we just proved with 7, then the quadrilateral is a parallelogram. So we're able to wrap up the proof. So we can say quadrilateral ABCD is a parallelogram, and then this is going to be a reason up here. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. 4.3 is coordinate proofs with the midpoint formula, but this time for triangles. So for this one, we're given that triangle ABC has vertices at -1, -2, 7, 2, and 1, 6. And then also there's a little segment in that triangle that has endpoints at D and E, and D has coordinates at 3, 0, E has coordinates at 0, 2. We want to prove that segment DE, that red one, is a midsegment of triangle ABC. So in order for it to be a midsegment, what a midsegment is it's something like a little segment inside of a triangle that attaches to the midpoints of each side, or two of the three sides. So in order to prove that DE is a midsegment, we just need to prove that E is a midpoint of AC, and D is a midpoint of AB. So we have to find the midpoint using the midpoint formula and then just see if it ends up being the same point as like D and E. So for 1, we're always just stating like what we're given. We can put them all in that same box. So for the first part, triangle ABC has those vertices at A, B, and C. And then the segment DE has coordinates at 3, 0, and 0, 2 for its endpoints. And then the reason is that it's given. And then, like I said, in order to prove that DE is a midsegment, we just need to prove that its endpoints are the midpoints of each side of the triangle, one side being AC and the other side being AB. So we're going to use the midsegment formula twice, like one for kind of each set of points. I'm going to find AB first. So we'll say the midpoint, this will be for segment AB, but the midpoint will be both the x's added together divided by 2, and then both the y's added together divided by 2, and then like I said, this is A and B. So it'll be -1 plus 7. So -1 plus 7, and then the y's added together, so -2 plus 2. So -2 plus 2. And then we'll go ahead and simplify. So the x's added together is -1 plus 7, so that's 6 over 2. And then the y's added together is -2 plus 2, so that's 0 over 2. And then from there, we can divide 6 over 2 to get 3, and then 0 over 2, just 0 divided by 2, so that's 0. So we got the midpoint is 3, 0, which is exactly what we wanted it to be because that's where D is. So we confirmed that D is a midpoint of AB. So for 2, we'll say the coordinates of the midpoint of segment AB are 3, 0, and then our justification is just the midpoint formula because that's what we use to find it. And then we're gonna do that same exact thing, but with the other like side of the triangle, so AC. I'm gonna do it off to the side over here. So for AC, the midpoint formula, so I'm like kind of writing over the graph, but the midpoint formula will be the x's added together over 2 and then the y's. So it's A and C, those will be our 2 endpoints, so it'll be -1 plus 1. So -1 plus 1. And then our y's are -2 and 6, so it'd be -2 plus 6. And then we'll add our x's together. -1 plus 1 would be 0 over 2. And then -2 plus 6 would be 4 over 2. And then we can divide to simplify. So 0 divided by 2 would be 0, and then 4 divided by 2 would be 2. So 0, 2 is the point that we got for the midpoint, which that's where E is. So that's the second thing we needed to show. So we did that. So for 3, it'll be the coordinates of the midpoints of AC, segment AC are 0, 2. And then same reason there, same justification. We just use the midpoint formula. And then now we need to kind of start building towards the end. So we just need to like kind of, I guess, not even like prove anything, but just like formalize it. I don't know. It's kind of late. I feel like formalize might not be a word. Okay, so for 4, we're gonna say that D is the midpoint of segment AB and E is the segment midpoint of segment AC. So because we just kind of proved that like the midpoints of AC and AB were, for AB it was 3, 0, and for AC it was 0, 2. Now we just need to like make the connections to point D and point E, and that's what 4 does. Because we're not trying to like just prove like those endpoints specifically. We're trying to prove that, you know, segment DE. So we had to make the connection that D was 3, 0 and E was 0, 2, and those were the midpoints of our segments AC and AB. Okay, and then for 4, like the reason, if 2 points have the same coordinates, they are the same point. So like it's not referring to like D and E being the same point, it's referring to E being the same thing as 0, 2, and D being the same thing as 3, 0. And then now that we've said like D and E are the midpoints, that's what a midsegment is it's a little segment inside of a triangle that connects to the midpoints of the two sides. So we're able to wrap up the proof. We can say that segment DE is a midsegment of triangle ABC, and then our reason is just definition of a midsegment, because a midsegment is a little segment in a triangle that connects to the two midpoints of the two sides.